All right. Good afternoon and welcome. Thank you all for coming here at 2 p.m. on Getaway Day. When I first saw the schedule for this session, it immediately reminded me of my first night away at college. I know it seems kind of random, but let me explain. I arrived on campus about a week early to go on a backpacking trip with about half the freshman class. And the first night, we spent it at random places across campus before leaving early the next morning. And I found myself laying on a tarp and thinking, I'm on this tarp on a soccer field in the middle of New Jersey, and I'm about to go on a backpacking trip with these 11 people around me for a week in the middle of nowhere. What am I doing here? And my worry was that you would be sitting here thinking, well, it's 2 p.m. in Las Vegas, it's about 80 degrees and sunny outside, and you're in the bowels of the Venetian, but you're not watching March Madness, you're not at a gaming table, probably don't have a beverage of your choice, although maybe you do. This is Las Vegas. So what I want to do first is explain why I'm here, and hopefully it'll help explain why you're here as well. Maybe you found yourself in a situation where you built a really great dynamic, interactive site. You know, beautiful graphics, dynamic content, you've got the weather. I took this screenshot while hovering over one of these news links at the bottom, and not only is it a dynamic flyout menu, but the contents of the menu are dynamic. And you rolled this out, and people said, well, it looks great, but it's kind of slow. And you went back and said, well, what do I do now? And I guess one option would be come back with this, you know, MSNBC from 1999. This would surely be faster than the current version, but probably isn't quite what your customers were looking for. So my name is John Hervatten. No, that is not a typo, and I would like to buy a vowel. I'm a lead program manager on the Internet Explorer team, and I want to make sure that you never have to make a trade-off between the functionality of your site and its performance. And I'm going to do that today by giving you ways to make your site faster today. Specific things you can do in your site, and it will get faster. I'm also going to try and teach you some of the principles behind some of these optimizations so that you can keep them in mind as you're building your next site, so it's fast right from the start. Some of the key takeaways and themes here is that all the suggestions I'm providing will make your site faster in all browsers. I work on Internet Explorer, so I understand its architecture better than I understand other browsers. So I can go in a little more detail in explaining why some of these optimizations work in IE, but all of these will make your site faster everywhere. However, there are no magic solutions here. You're going to have to make some trade-offs here and there with regards to maintainability versus optimization, and we'll talk about how you make some of those trade-offs and how you get the necessary information to make those types of trade-offs. And because it is a talk where I want to give you specific examples in code, there is a lot of JavaScript code, there's a bunch of CSS, so I assume a general working knowledge of those technologies, which I don't expect to be a problem with this group. The content of this presentation is one that's been built up over time. I'm not the first person to present this general talk, although we update it every time we give it. So the content here isn't just me sitting down in a room by myself. It's things coming from people like Steve Souders, the author of High Performance Websites, from others on the IE team who've given this before, some of whom are in various parts of the room today. And in a lot of ways, it's things that we've learned as we've been building Internet Explorer. And that's one of the things I'd like to start with. When we began IE8, we wanted to figure out what are the areas of the browser that we should focus on to make IE8 faster. And to do that, we wanted to understand where we were spending the most time. So we did some testing, and we were loading the top 100 websites, and we profiled and said, where do we spend the most CPU time? Now, how many of you, raise your hands if you think IE would have spent more than 50% of its time within the JavaScript engine and the DOM? Anyone? How about more than 25% of time? A couple of people. Well, in reality, it's only about 16% of time in JavaScript and the DOM while loading the top 100 websites. And I know what you're probably thinking. Great, Craigslist doesn't run a whole lot of JavaScript. So we also took the top Ajax sites. We took about 30, and this includes things like Google Maps and Gmail and other JavaScript-heavy applications. And we found that while the time spent in JavaScript and the DOM clearly increased for these, in fact, it doubled, it was still only a third of the time spent in all of the browser, all the time the browser spent loading these sites. So we knew that we had to, when we were looking at making IE8 faster, we had to look across the entire application. And that's one of the key points for you guys as you look at your websites. If you want to make it faster, you can't just focus on the JavaScript or its DOM access. You have to look at all areas of your web application. So today we're going to talk about a lot of different areas of performance. We're going to talk about HTTP performance and how you can use caching to optimize your site and other techniques for reducing the number of network requests you use. We will talk about JavaScript coding inefficiencies, because that is clearly an important part, as well as optimizing symbol resolution within JavaScript. But we're going to start by talking about CSS performance. The first rule here is pretty simple, but it's one that I think in practice people don't always follow. It's that you want to minimize your included styles. Obviously, if you have a bloated CSS file, this is going to increase the bandwidth you use when downloading that CSS and the time it takes to download it. But you're also forcing the browser to parse and match all of these selectors that simply end in no match. So you're asking the platform to do a lot of work that's simply unnecessary. Now, in practice, this happens a lot because it seems really simple to have one huge CSS file for all 100 of your pages, and have every page include that one. But if you can come up with a build process or some other way of only including the styles that that particular page uses, you can actually see pretty dramatic performance improvements. Another way to optimize CSS is by simplifying your selectors. The principle here is, again, that if the browser has to do a lot of extra work to match some of these complex selectors, it's going to take a little bit more time. So instead of using element selectors that the browser has to go through a lot of work to find those elements, those particular elements, use class or ID-based selectors. Most browsers have different optimizations for looking up elements by their class or ID because it's done so frequently in script. So if you use those same techniques in your selector matching, you can take advantage of those optimizations that are already in the browser. Another tip here is, if you are going to use element selectors, you want to make them as simple as possible. And a good example here is that instead of using a child selector, use a child selector instead of using a descendant selector. If you have a descendant selector, the browser has a much more complicated algorithm to follow to determine if that matches, because it has to search all the descendants of that element. If it only has to look in the children, it can do this matching much, much quicker. And obviously, if you're only including the minimum number of styles required, it's much easier to do these things. You don't have to find these ways of targeting this one element versus another one. And you'll notice I have a little badge down here. So while all the rules I'm telling you will improve your sites in all browsers, I do work on the Internet Explorer team. We did release Internet Explorer 8 yesterday. So I'm going to point out a few of the places where Internet Explorer 8 makes this process of optimizing your site or making it as performant as possible much easier for you. And this is one of the areas that we looked at heavily and found ways to optimize different element selection, different selector matching. So a couple quick examples. Here I have a list of element selectors that, if possible, if I can simply use pass here, I can make this much easier and much quicker for IE or any other browser to perform the match. And the other example I talked about is, instead of using a descendant selector, you can use a child selector. If that meets your scenario, or if you can try and make this meet your scenario, you'll end up getting much better performance. This next one is built on top of a recommendation that Steve Souders included in his book on avoiding using expressions. And the reason for that is that Internet Explorer evaluates these expressions in much more frequently than you might think. And in the end, it slows down your site quite dramatically. Now, I've made this recommendation a little bit stronger and said, just don't use expressions, because they're no longer supported in Internet Explorer 8 standards mode, which is the default rendering mode. That's because these expressions were not CSS standards compliant, so they no longer work in our latest, most standards compliant rendering engine. So it's a good idea to simply stay away from expressions as you're writing new sites. If you have previous sites that use them, it may be something that you have on your list of things to slowly work out of your site. Another example, another tip here, this isn't as much directly CSS. It's more of a site architecture issue in general, but it has to do with layout, so I kind of group it into CSS. And that's that you want to minimize page relayouts. So the idea here is that frequently you're building a dynamic site. It's not just the HTML that comes down through the wire that your user sees. You have script that builds the site, changes things. Maybe there are ads that come down later that take longer to load. And the principle here is that you want to minimize the amount of content on the page that has to update as new content comes in. So I'll do my first demo here. So what you'll see when I load this site is that the text that the user wants to read, in other cases this could be a form they want to fill out or really anything they want to interact with quickly, is displayed on the page nearly immediately. But because of the way I've dynamically built the rest of the site, it doesn't quite make for a great user experience. Now, I made this a pretty extreme example. I set some timeouts and made sure these came in slower. But if you were trying to read some of this text, you realize that first it dropped down, and then it started word wrapping. And this would be pretty jarring to the user. It also makes the page appear slow. And in the end, you're asking the browser to recalculate and relay out tons of content on the page just when these new elements come in. On this other example, I had the same timeout set. The script loads at the same time as it did in the previous example, but I just set placeholders. I happen to know that the dynamic content I'm adding has a strict size that I know ahead of time. So I'm just going to create a placeholder and make sure that size is set. And that way, to the user, it seems pretty natural. They can interact and read the main content on the page without this while this other content comes in. It also lets the browser optimize the layouts it does. So when IE goes to add the header and download these other elements, they don't have to recalculate the layout of the rest of the elements on the page. Summary here, quick takeaways. You want to minimize the included styles that you use. You want to use the least complicated selectors that you possibly can, which is obviously much easier to do if you're minimizing your included styles. Don't use expressions, and if you already have them, start to weed them out of your site. And finally, minimize page relayouts by understanding how your site updates and keeping changes, the dynamic portions contained to certain areas of the page. And the general rule here is simplify. The next topic I'll discuss here is optimizing symbol resolution. Symbol resolution is the process that any JavaScript engine goes through to determine the value associated with a name or a symbol. So this is as simple as I'm using a variable, and I have a name for that variable, and the JavaScript engine has to understand what value does this variable refer to? Or here's the name of a function or a method. What does this name refer to? And as you all are familiar with JavaScript, you'll know that the first place that the JavaScript engine looks these things up is in the local scope. It's the first place first place it looks. But if we can understand a little bit more of this whole chain and how the JavaScript engine looks up these values, we can learn how to optimize our code around it and make sure we get the best performance possible. One of the ways I like to think about this is if I've lost my keys or I can't find my keys, I have a couple different places I look to. And I don't always go to the most expensive place first. I don't look in my attic for my keys. I check all the most likely places they are. So when the JavaScript engine sees something like var name, or then when another JavaScript statement uses that variable, the first place it looks is the local scope. This is a very inexpensive and quick lookup. But if it doesn't find it here, it's going to start looking through all the intermediate scopes. JavaScript is a lexically scoped language, which means that the scope that's available to any specific JavaScript statement depends on where that function was defined rather than in the way it was executed. So I'm going to look up all these intermediate scopes. There could be none, there could be many. And if I don't find it there, I'm going to look all the way in the global scope. And each one of these lookups increases the cost. It also just takes a lot longer as I do more and more lookups. There's another lookup chain called the prototype chain. It happens anytime you are accessing a method or a property off of an object. So similar to the scope chain, there's the first place you look, which is on that particular instance of the object. The second place you look is in a prototype chain. If I've created a prototype for that particular JavaScript or NIE8 DOM object prototype. And finally, I'm going to access the DOM itself and look up this particular method or name in the DOM. Now, what does this actually mean for your code? Well, here's a simple example. And when I first looked at this, it seemed pretty innocuous. So what could I possibly optimize in these 2 lines of code? And the problem here is that although I think I'm working on a local variable, I haven't declared this variable as local because I don't have a var keyword. So what happens in this case is the JavaScript engine walks through all those lookup chains and eventually creates an expando off of the window object. So that first statement that sets that variable is incredibly expensive because it has to access go all the way through the JavaScript engine and all the way into the DOM to set the value. And then every time I access it again, I'm making that same trek all the way into the DOM. So a simple way to optimize this is add the var keyword. You're taking knowledge you know about your code and making it explicit to the JavaScript engine and to the browser so that they can optimize around it. Another tip here is to recognize implicit lookups. So if you read through this code, first line, I'm using getElementById and setting an element, and then I'm clearing the contents using inner HTML. So that's a first access. Now, inner HTML is part of the DOM. So again, this is a rather expensive call, or at least the most expensive when it comes to working in JavaScript and doing symbol resolution. And then each one of these other ones is actually 2 lookups. So I'm getting, with the plus equals operator, the first time I'm getting the value, and the second time I'm then setting the value. So in total here, I have 7 references to inner HTML. I can optimize this by batching up changes. So if I have a lot of work that I want to do in a certain area of markup or in a certain area of the DOM, rather than repeatedly access the DOM one after another, I'm going to build up all my changes within the JavaScript engine. Here, I create a variable, and I call my build title, build body, build footer on it. And then I only access inner HTML once. And in a little bit, I'll go into and show you actual numbers in a profiler of the impact that this sort of change can make. And I'll do that for all of these. Here's another example of recognizing multiple DOM lookups. In this case, I'm calling the same chain of elements several times. And each one of these requires several lookups. So I first look up the document. OK, there it is. Now I look up body. There it is. Now I look up all. And I'm going to do that every single time. Simple optimization. Cache that element collection once, so that you only have to do 1 lookup each time you access that element collection, instead of frequently doing document and then body and then all. And the same thing that we've been talking about for variables also applies to functions. So here I have a function that I'm calling several times in a loop. And the JavaScript engine has to look through, perform this symbol resolution on this method name as well. So if I create a function pointer, I can call that function pointer in my loop and optimize the amount of time optimize that symbol resolution. And you may be asking yourself, OK, is this really the type of tiny little optimization that I need to make on my site? Are these really the performance problems? Or are these really what's impacting the performance on my site? And the answer is it depends. So this is when it comes to when having the right data about your site's performance is very important. So while you want to watch for expensive name lookups and cache repeated lookups to local variables, you really want to only do these optimizations when you need to. And you want to consider the maintainability of your code. I'm certainly not standing here recommending that every time you call a function more than one time, you should create a function pointer. It seems a little bit like overkill. But if you're going to call that function pointer several times, it may help you. And the question becomes, well, how do I know when that optimization is one that I need, or when that optimization really helped me? And that brings me to my next demo, which is the JavaScript profiler. How many of you have used the built-in developer tools in Internet Explorer 8? Okay. So I'll do a quick 30 seconds on the developer tools. The developer tools in IE8 are built in. Every installation of IE8 has them. So you go into IE8, and through Tools, Developer Tools, or by simply pressing F12, you can load up these built-in tools. These have a lot of functionality to help you debug your HTML, your CSS, has a full JavaScript debugger, and the piece that we're going to look at most today is the profiler. So in this page, get a little bigger. All I have are all the code examples that I just showed you on the previous slides. So you see test 1 is working on local variable without the var keyword and with the var keyword. And I've done this for each one of the samples that I showed you earlier. And now, simply click Start Profiling, run tests, and click Stop. And now I have all the timing for all those methods. The default view here shows me the number of times the function was called, the inclusive time spent, the exclusive time. It also gives me a lot of additional information that I could add, sort columns, everything you'd expect from this type of view. You'll see that the URL field is here, but it's blank. It's because I don't have script debugging enabled. I always run without script debugging enabled because script debugging in general can slow down the browser. So in this case, I wasn't too concerned with showing the exact URL because I know where all these are coming from. But now I can look through my code and see which one of these really made a difference. So here's this work on local variable. And you can see that the amount of exclusive time I spent in this function definitely did decrease, but maybe this wasn't the most important. The percentage isn't necessarily that high. But if I look at a couple of these other ones, so here's build UI. This is the one where I went from 7 references to inner HTML to a single reference to HTML. And I went from 497 milliseconds down to 171 milliseconds. Now, this was a pretty small example. You can imagine if you're doing this on a large site with lots of elements, it can have a pretty dramatic impact on your own sites. And understanding which of these is most impactful for you is really where the profiler really comes in handy. Also wanted to point out, I don't know how many of you have seen demos or betas of Visual Studio 2010. They also have a JavaScript profiler that will not only help you find some of the bottlenecks in your client-side JavaScript, but help you look across your entire web application and see those within the Visual Studio environment. I'm not going to spend any time today demoing that product, but I wanted to include this slide here so that if you guys download the slide later or view this video later, you can go to this Channel 9 video and check out a demo of it that they gave at PDC last fall. Okay, next topic is JavaScript coding inefficiencies. How many of you use JSON, or JavaScript Object Notation? Yeah, quite a few people here. How many of you when you get the JSON data, how many of you use eval to turn it back into a JavaScript object? How many of you use a custom library to do the parsing? Okay, good. So this is one of these places where what I call it's just a classic trade-off, one that we at Microsoft do with a lot. And that's, well, eval just executes whatever that JavaScript is, which isn't necessarily the most secure thing if any of that data is untrusted. And a custom library, while that can clear out and sanitize that JavaScript, it's also much slower. Now, the catch here is that eval is actually not that fast either, because it creates an entirely new script execution context in which to run the parser on this string and execute it. But here you're still stuck with this kind of poor choice. At the beginning, I talked about a trade-off of performance or functionality that we never even want to have to address that. There are other trade-offs of maintainability versus this optimization. And here's one of performance versus security. And that's another trade-off that we just never want to have to face. So in Internet Explorer 8, we've included a built-in JSON method. And this JSON method is just as safe as any of these custom libraries written in JavaScript that do the parsing, but it's native, it's built into IE, and it's incredibly fast, significantly faster than any of these custom libraries. This is available in IE8, in IE8 standards mode, and I believe it's also now available in the Firefox 3.1, soon to be renamed 3.5 beta. So this is going to be something that you'll be able to use in the future on several browsers, and I would expect that other browsers pick this up too, because as you can see just from this room, JSON is an incredibly popular feature, and performance versus security is something that we never really want to have to trade off we really don't want to have to face. So the JSON object has methods to parse and stringify. This is, I know a lot of people look at stringify and say, is that really what it's named? And well, we kind of did too, but we wanted to make sure that this was part of, that this matched the ECMAScript 3.1 draft that currently exists for JSON. And I think this is something that all of you in this room can go back and look at, okay, how do I use this new JSON object in IE8 and really take advantage of some of the performance and security benefits. The switch statement. Here's another one that when I first looked at this, I had no idea that this would be a performance concern. So my background in computer science is in C and C++. And one of the things I remember learning in some compiler class was about how the compiler would take things like this and optimize it. So it isn't just an if, else if, else if, else if. They turn it into a hash table or some sort of lookup table that would improve performance. And what I've learned recently is that JavaScript engines don't do this. This really does just become if, else if, else if, else if. And in many cases, with your switch statement, this isn't that bad of a thing. This is, again, where a profiler comes in handy. But if you're doing a switch statement with something like 1,000 cases, and you find yourself frequently going to the default or using one of the later cases, this can be pretty slow and can really take some time. So better optimization here is to do what the compilers do in other languages and optimize this to be a lookup table. So you have created a lookup table with numbers as the reference, and I use a try-catch block to look up into that table. This is another place where, wow, that switch statement was so clean and easy to write. Everyone understands it. Something I've used for a long time. And do I really want to do all this work to change it into a lookup table? This is one that you definitely want to run through the profiler, understand that this is your bottleneck, and see what type of performance gains and improvements you can get from this. Another one is property access methods. I know a lot of times we all like to write really, really clean code that does things like get property and set property and use methods for these rather than accessing that property directly. But the problem is this creates a lot of overhead. So anytime you do a function call, you're going to have overhead of creating that function scope and executing that function, even if it's doing something as simple as just returning the property. And in fact, because all it's doing is returning just the property, the overhead is a huge percentage of the time it takes to run this code. And a much simpler method is simply use the direct access. If there's not doing anything in that function except returning the property, just access the property directly. And this just kind of points out the cost of instantiating these DOM functions. But it's a little bit more specific for this case. Now, when we talked about the lookup chains, you see that we talked about the DOM as kind of the last place where we look anything up within the JavaScript engine. And DOM access is actually pretty costly. I think of it like if I have a bridge, if I have 2 pieces of land, I got a bridge, and it's a toll bridge. And the JavaScript engine's on one side, and the DOM's on the other. And every time I want to access the DOM from the JavaScript engine, I'm going to have to pay that toll. So I really want to think about how many times am I crossing that toll bridge, because it's really accessing that point that gets costly. And like I have my little badge up there. This is something that we've improved in Internet Explorer 8 quite dramatically, actually, over previous versions. But this is something that you should still pay attention to, particularly in certain scenarios. And I'll point out some examples of where this can really make a difference. I'll explain the architecture a little bit more. So the DOM, or the document object model, sits within what we refer to as Trident, and what you may know of as mshtml.dll. This is the main rendering engine and really the platform piece of Internet Explorer. And the DOM sits within that. The JavaScript engine and the Microsoft implementation we call JScript sits in another DLL. And they talk to each other through an abstract interface. This is great for plugging in any language that you want. And this is, in fact, how a lot of browsers do this. You'll see things like other browsers where they use one rendering engine, but they somehow implement their own JavaScript engine. So there are these interfaces and this kind of abstract communication between the two. But it's accessing these that can really cost your application some. You'll really pay a performance penalty. So here's an example. I gave a version of this talk back at TechEd EMEA last November. And the day I was speaking, I got an email to one of our internal JavaScript IE aliases, the distribution lists, that said, hey, I wrote this code. I was trying to implement get elements by class name, and it was really slow. And I found this other method that was fast, but I have no idea why this is faster. Can you help me explain? And this was perfect, because it was 4 hours before I was about to go on stage to present. So here's this example. For brevity, I cut out some of the code here. But the key points are looking at how many times I'm crossing this bridge to access the DOM. So here's one where take my variable elements and do node.getElements by tag name. Then I'm going to iterate through this collection. And for each iteration of this loop, I'm going to have to access the DOM to get the length, as well as to get the item out of that element collection. And if this is a huge collection, if length is really large, this can be pretty slow because of all this DOM interaction. And this is the code that this person had been able to come up with on their own that made it a lot faster, but just didn't understand why. And kind of the key here is that instead of continually accessing the DOM, they took that same element collection, ran one loop to copy it into a JavaScript array, and then only had to access JavaScript. And I think the speed up in their site was something like it was 80% faster or something dramatically improved for most of their scenarios. And I think this is just a great example of a place where the more work you can do within the JavaScript engine alone, the more performant your site can be. Even if you may look at this and say, well, now I have to pay the price of doing this loop and doing this copy of all these objects into the JavaScript array. This is another place where the profiler really comes in handy to understand, well, maybe I never have an element collection that's large enough to make this worthwhile. And that's something that you have to understand and look at for your own websites. So in this case, again, I'm only accessing elements .length and this elements collection, but this time that collection is in the JavaScript engine rather than the DOM. Another tip here is using DOM methods when they're available. So if your code is simply walking through a child nodes collection one by one by one, and there's a built-in method like next sibling, typically it pays to use the built-in method because we've optimized for that. We know exactly what you're trying to do. So here's an example where I'm accessing nodes, and I'm just incrementing incrementing my index each time. And this is much more performant if I simply call next sibling. Kind of general rule here is built-in DOM method for it, probably quicker and much more performant than doing it yourself. And this next example is a new method, is a new feature that we've introduced in IE8, and it's the W3C's selectors API. How many of you are familiar with the selectors API? Any people? How many of you are familiar with the CSS selector syntax? More people. So the selectors API lets you use selectors, the CSS selector syntax within JavaScript to find elements in the DOM. So you can see in this first line of code, I'm calling document.querySelectorAll, which is the name of this, the selectors API. And the text I'm passing to it looks like a CSS selector. And what this will do is return all the elements that the browser would have matched for this particular selector. This is incredibly powerful because it's a very flexible language. You can customize exactly the elements you want. And when you're looking for a large collection of elements, this is actually much more performant than frequently calling getElementById, than repeatedly calling getElementById. And this is another place where the browser can take advantage of optimizations we have. Like I mentioned, we've optimized doing CSS selector matching for matching rules. We can take advantage of that same rule matching and optimizations when you call the W3C selectors API. Okay, takeaways for JavaScript coding inefficiencies. Use the native JSON object whenever you're using JSON. This is a new feature in IE8, and so you'll have to have some level of fallback for previous versions of Internet Explorer, as well as for other browsers that don't yet support JSON. But as I mentioned, Firefox will in a future release, and I wouldn't be surprised if other browsers added it as well. You want to turn your large switch statements into lookup tables. You want to avoid property access methods. It's much quicker to simply use those property access directly. Minimize DOM interaction. And finally, use querySelectorAll if you're searching for groups of elements. And again, the meta points here are you really want to optimize only when you have to, which is where tools like the profiler come in very handy. And you really want to consider maintainability. You don't want to rewrite all of your code just to find that it hasn't gotten any faster. You want to be able to do some of this testing and understand where your bottlenecks are, the same way we had looked at Internet Explorer and said, hey, where are our bottlenecks in real-world web usage, and then optimize there. Okay, final topic here, collection of tips here is around HTTP performance. So typical visit, you request from the server or from the cache in some cases, and you download all your JavaScript, you download all your CSS, your images, your HTML, and the browser does a whole lot of work to do the layout, executing the script, and kicking off all these additional downloads. We've talked about the work in the browser, and this section will focus primarily on requests from the server. And this first tip is about reducing the size of those requests. So HTTP compression, pretty standard thing these days. Recommendation here is to use it. In the request, accept encoding should include gzip, and if your servers are configured to use gzip, you can gain a lot of performance by compressing the content. One catch here is that while this compression is really great for text, HTML, CSS, JavaScript, you never want to do this on something that's already compressed. So never use gzip on a JPEG, for example. In the best case, your JPEG will be exactly the same size, but you'll have wasted CPU and client-side cycles compressing and decompressing it. And in the worst case, you'll have times where the JPEG gets bigger. This is simply a factor of how compression works and when you compress something that's already compressed. But again, one of those things that seems obvious, but in the real world, you don't always think of. Scaled images. Okay. If you have a bunch of icons on your site, small images, you set the width here to 50 by 40, make sure you're not downloading a file that's 500 by 400. It's simply unnecessary. Again, simple thing, easy to forget. On the IE blog, we posted a little post at New Year. It said, hey, Happy New Year's, everyone. We put this nice picture of, I think it was a champagne glass and a party hat or something like that. And it was a massive image. It was just this quick post we put up, hey, here's an image, go, didn't even think about it. But man, people noticed because this was a huge image, really didn't need to be that large. So I think of a great example of the things that, small checklist of, hey, did I do my performance checklist to make sure I haven't done anything silly today? We had that day. So simple optimization, use a sized copy, exactly what you need to. file linking. So this one is about not just reducing the size of what I'm downloading, but I also want to think about the number of downloads I do. The number of HTTP requests and responses that I go through also take overhead. So in this case, if I have multiple script files and multiple CSS files, I'll save on a lot of that overhead if I simply include one of each. So try and combine all of your JavaScript into a single file and link that. And you want to combine all of your CSS into a single file and link that. And another point here that I actually unfortunately don't have a slide on is that you may say, well, what if I just inline this content? Won't that get rid of the network request entirely? And the reason you frequently don't want to do that is because you want to be able to take advantage of caching. If you have the same CSS or same JavaScript file that you use on maybe your top 10 different HTML pages, if your user goes to that first page, the browser downloads that HTML, that JavaScript or CSS, you go to the next page, the browser can use that from the cache. If you're inlining it all, then you can't take advantage of caching at all as you go from page to page. So for typical sites, you'll find that using a single JavaScript and single CSS is the best method to balance minimum number of HTTP requests and responses, as well as being able to take advantage of client caching on the client side. Another way to reduce the number of images is a technique called CSS sprites. Anyone ever use CSS sprites or heard of them? OK, good. So in this case, I have a series of images, and they all have their own image element, and the browser is going to have to download every single one of these images. Using this technique called CSS sprites, I create one large composited image on the client, on my own time before I, in a Photoshop or another application to composite all these images. And then instead of using image elements, I'll use divs. And I'll use CSS to take this one huge image file with all of my individual images and set them as the background image of these divs. And I'll use CSS to position that background in just the right place under my div so that it looks like that's just the image there. And this is a great way to reduce the number of HTTP requests that you're getting. You may wonder, well, is this just going to bloat the size of my images? I'm going to have all this white space or other space in between. And frequently, this won't grow the size of your image files as much as you might think because of things like the compression that JPEGs use or compression that other image formats use. They can do a pretty good job of getting rid of a whole bunch of empty white space. The next piece that we want to talk about is really about repeat visits. So this is someone who's coming to your site frequently, all the time. This is when you really want to make sure that you're taking advantage of the cache. So the first way to do this is by creating conditional HTTP requests. So instead of creating just a plain HTTP request, you set an if modified since. I'll show you an example of that first. So in this request, I'm downloading this banner image, and I ask if it's modified since this date. And if it's not, I'll get back this 304 not modified, and I know I can use this image. But the problem here is that I'm still asking the server to do this check and getting the network response back. I can optimize this even more if my original HTTP response from the server includes what's called a far futures expires header. So I'm going to say that I know that this image is going to be good until June 12th, 2009. So the next request that the browser sends can immediately be served from the cache, and we don't even have to worry about having the server send us a 304. Here's one that, I don't know, in talking to a few people this week, there were people I think who hadn't heard of this recommendation before. It's one that we had blogged about on the IE blog. I think it was probably 4 years ago now. But the idea is that you always want to link your CSS files at the bottom of your site. And here's why. Whenever a browser hits a script tag, it stops doing anything else. And that's because it's worried that the script that it's downloading or the script that it's executing is just going to go change the rest of the site. So why waste all those CPU cycles working on the rest of the page? What this prevents is progressive rendering, because the user's just sitting there waiting for this script to execute rather than watching the HTML load into the page. Now, this is one thing that we've improved in Internet Explorer 8. So instead of going through and blocking at a script tag, Internet Explorer 8 continues parsing and kicks off additional downloads. In addition to this improvement, in addition to changing our default connection limit, so now we can have 6 connections per domain at once, this has made huge performance improvements within IE8. There are some tests on, I think it's again Steve Souter's perf website, that points out that there was very simple pages that would take 10 seconds to load, and in IE7 or in Firefox that now take 4 seconds within IE8 simply because of this optimization. So you can get similar benefits if you do this on your own site. You get these similar benefits in other browsers if you do this on your own by putting script tags at the bottom. Now, sometimes the content that you want to load and progressively render, the user has to interact with, and maybe that's dependent on script. We were recently debugging some bugs and site compatibility issues we saw in SharePoint during IE8 development. And I learned how they handle this, and I thought it was pretty clever, so I wanted to explain it. They have a script tag in their head, and it's incredibly small. It's this minified JavaScript, the minimum that they need to set up some basic functionality. And all it really does is set up an error handler. It says every time there's a script error, update the status bar to say, please wait while scripts are loaded. And then they have their huge, massive JavaScript file to handle all the rest of their functionality, and they link that at the bottom of their site. Or actually, I think they do it at the top, but set a defer tag, which is effectively the same as putting it at the bottom, so that that file can be downloaded, but the user still sees the full site, can click on a hyperlink, go to the next site, and if they happen to click a menu or something that uses JavaScript that isn't there yet, they're not going to get a script error or this broken experience. They'll get this warning or little message that just says, hey, please wait, scripts are still loaded. And I thought that worked out pretty well in working around some of these, some of the architectural or processes that browsers go through for loading sites. One other one that again, I don't have, unfortunately don't have on a slide here is linking CSS files. CSS is one that, unlike JavaScript, you want to put at the top of your content. And the reason for that is to avoid what's called the unstyled flash of content. So if this is where you load a page and you see all this great default text and all your content without any styling, and all of a sudden the styling applies and you see it kind of filter in. To avoid that, if you put all your CSS linked at the top, the browser has all the style information, and the first time it lays out all the content, it can make sure it's all styled at the same time. So just like tools were an incredibly important piece of optimizing JavaScript and understanding where the bottlenecks are, the same thing is, of course, true for networking and HTTP performance. So here, the primary tool that's available that we recommend is Fiddler. I assume Fiddler, people have used Fiddler, I assume? OK. Because most places we go, people have seen it. I don't spend much time demoing it here. There is a new plugin that was just released that I have a link to. Unfortunately, this was literally just last week that I learned about this, so I haven't had time to really set up a demo for you. But I wanted to make sure I link to it as a new plugin for Fiddler that will help in performance testing while using Fiddler. So kind of the summary, the takeaway here for HTTP is you want to reduce the number of requests that you have. You want to combine external scripts, styles, and images, and you want to use caching. You want to reduce the size of requests by using things like HTTP compression and conditional requests. And you also want to avoid blocking factors by putting script at the end of your HTML. Kind of a summary. The main steps here are, understand your own site and your own application and find out where these bottlenecks are by using tools like Fiddler or IE8's built-in developer tools and understanding what your network bandwidth looks like, what your JavaScript performance looks like, where am I accessing the DOM aggressively. And then you want to reduce, simplify, and refactor. Reduce the bytes sent across the wire, simplify your code so you can avoid some of these really costly JavaScript and CSS constructs, And then cache your DOM properties in function pointers so you can optimize those sites, those behaviors. So that's what I have now. Obviously, we have plenty of time. I wanted to make sure we had time to ask questions. I know frequently in these types of, for talks like this, people have a number of good questions. We also, I think, have some fun things in the back as people, maybe we can bring those up and people can come up and grab them after we're done. But if people have questions, we have a microphone there. You can also just raise your hand and I'll be happy to repeat it. And the last thing here is please complete the evaluation forms. They're all over the chairs. It really helps me understand what worked and what didn't, and to make sure that we can make the next session better.
Yeah, so you said that if you put the CSS at the bottom, that the page will flash at the end, but you'll get great performance. If you put it at the top, it doesn't flash. What if you want it to be fast and you don't want it to flash?
That's a great question. So I think that's when using some of the CSS techniques that improves the styling, that improves the speed with which the browser can go through and load and match those styles. So if you optimize your CSS, so it's the minimum number of included styles, you're using simple selectors, and then put it at the top, you can reduce some of the, and only one CSS file at the top rather than several. You can still get some of the performance of, okay, even though I have the CSS at the top, it's not going to dramatically slow down my site, and yet you can still avoid that flash of unstyled content.
Hi, nice talk, by the way.
Thank you.
You said you have a background in C++, so you must know that that example in C++, like the thing you did with the switch statement, where you put all the, and then you had a try-catch block. You must know that that's an anti-pattern in C++ because of the overhead of setting up exception handling and everything like that. Is that not the case in JavaScript?
I don't believe it's the case in JavaScript. I don't think that overhead is really going to overwhelm the performance benefits you get by using the lookup table instead of just the switch. And again, it's really dependent on the size of that switch statement. I mean, if I haven't done enough testing to know exactly if it's like what the barrier is. Well, if you have more than 50 cases, then it's more performant to do this way. I haven't done that myself yet, but it's something that you could probably quickly do in script with the profiler.
Thanks.
Hi, I had a question regarding the HTTP compression. You mentioned that it should not be allowed, it should not be implemented for binary objects like images inside the HTML. So what I was wondering was, I had two questions actually. Well, one, what I've seen, the way I've seen the implementation of HTTP compression is defining it in the headers, right? Or on the IES. So how can you classify what objects to compress and what objects not to compress? The second question was about the overhead of using the compression. We know that it takes a bit of processing cycles to compress. So what would be the best practice to make sure that we apply it at the right, on the right pages? So I was just wondering if you could share your experience.
Yeah, sure. So I think the first question was, how do you configure your server such that you can use the compression on the correct objects and content rather than just putting it everywhere and getting some of the negative impact? That's a very good question. I actually don't know the answer to that. I'm a little bit behind on my server configuration. I'm spending a little bit more time on the client side, but that's a good question, and it's one that I'll make sure that I have an answer for in the future as we give these talks. The second question you had was, sorry, remind me once more.
It was about the overhead, the CPU overhead for compression. So what would you recommend as a best practice to make the call whether or not you should
use the compression versus the server cycles? I don't have a rule of thumb. I think it's really the testing. It's understanding, in my particular site, is server load and server CPU cycles my bottleneck? Do I really want to optimize there? And in that case, if all my users are on T1 lines, but my server is maybe overloaded, maybe don't have the hardware I wish I had, of course we're all probably in that situation, but if my server is stressed sometimes, in that case maybe it's best to avoid the compression. But it really just depends on your own testing and understanding really where your own bottleneck is. And that's a great point because I talked about bottlenecks around HTTP and CSS and JavaScript, but if your bottleneck is on your server-side performance, something like compression is something that you really need to take into account in deciding whether or not compression is the right thing to do.
Can you recommend any tools that can help identify how, what amount of overhead does the compression, could take in big...
Would take on the server, you mean?
Oh, yeah.
I don't know of any. I don't know if, Eric?
So just to answer the backing up a little bit, for the line types on the server, you can actually usually, for both IS and Apache, you can decide which line types you'd like to compress. You can also do it on a per folder basis. You can say compress everything in this folder and not in this other folder. Both, and I know IS supports this, and I suspect Apache does as well, where it actually does dynamic compression caching. So essentially, if you have static content which doesn't change, it will actually just compress it once and then put it in a temporary folder, and as long as that file doesn't change, it'll redeliver it. So really the overhead question is about the dynamic pages that you're generating on the fly. And so you have to figure that out, as John mentioned, basically dynamically, what's my trade-off and so forth. But very often you'll find that you actually get better performance even doing the compression because the compression stuff is usually very highly optimized. And the amount of time that the server has the TCP/IP connection open to the client and streaming out the bits, it often works out to be better that way. And so there are a couple of companies that sell tools that will help you try and optimize and decide and so forth, but unless you have a very, very specialized config, you're usually better off just using either Apache or IS directly.
Thank you.
Thank you. Eric is another program manager on the Internet Explorer team who does, I don't know if you saw his security talk yesterday, also previously did networking for IE7. Yeah. Okay. So yeah, so what was that URL? Port 80. Okay. Yep. Okay. And there you go. So Fiddler also has some of the functionality that tells you what you'll save with compression, and the Nexpert plugin also does that as well, probably in a little more focused, performance-oriented way. Yeah. Yeah, it's great. The comment was that there are also ways to modify the amount of compression and scale it up or down based on your own situation and the load on your servers. Thank you. Yeah.
You mentioned that the CSS matching can be expensive to resolve the selectors. Is there such a thing as a CSS matching profiler where you can see, for a given selector, how long it's taking?
That's an excellent question. So my main feature of my area that I worked on for IE8 were the developer tools. And I'm sad to say that I don't know of a tool like that. I wish we had one right there. It was something that we kind of thought of and saw later in the product cycle as we were figuring out more about IE's performance and optimizing it. But I think it's one that there's a huge need for. Because as you can see, we have, hey, here's this tool for JavaScript, here's this tool for networking. And when it comes to CSS, I think there's kind of a hole right now. I think it's a great opportunity to write some good tools, even as simple as doing selector matching and deciding if they're finding rules that don't match any elements in that particular page. Simply doing that sort of element matching, it'll help you filter out all your unused rules so you can follow that first tip I gave. But yeah, I don't know of any today. If anyone does, I would love to hear about them. I think it would be a huge tool, and if it's a good tool, and reliable and everything, I'd love to add to these talks for the future. Other questions, things people have? I'll be around for a little while afterwards. Obviously, it's we still have some time. Thank you again, all of you, for coming here today. I really appreciate it.